Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, guys, we're going to talk about radical equations and their applications. Just like everything in math, we have to learn the technicalities of it before we can actually apply it into real-world situations. And we already know how to simplify, multiply, divide, add, and subtract radicals. We also know how to convert exponential form to radical form and radical form to exponential form. And now the next logical progress is radical equations. Now, a radical equation is an equation that has a variable inside of the radical. It's part of the radicand, okay? Has a variable in a radicand or a variable with a rational exponent. Remember that you can have square root of x, or you can have x to the 1/2. It's still inside of a radical. So when you have a variable as the radicand, that's a radical equation. In this lesson, okay, we're going to assume that all radicals and expressions with rational exponents represent real numbers. And we have to define that because I'm going to be teaching you guys imaginary numbers and complex numbers tomorrow. So, procedure. Just like anything else, guys, there's a procedure. Luckily, this procedure is almost identical to solving multi-steps equations. Number one, isolate the radical, okay? I want to get the radical by itself. Now, please be careful. That does not mean that I want to get rid of whatever's inside of the radicand. I want to get the radical alone. This is where vocabulary is very important. If I have, for example, square root of x plus 3 minus 2 equals 9, I want to add 2 to both sides so that my radical is by itself. Again, many people will tell me, Memoro, they're adding something to the x. Yeah, I don't care about that. But the radical's by itself at that point. Nothing's being added to that radical. Nothing's being subtracted from that radical. Nothing's being multiplied to that radical. And nothing's being divided from that radical. Okay? And then from there, we're going to go ahead and solve, and I'll teach you how to do that in a second. But that's what that means. Isolate the radical. Get it by itself. Number two, cancel out or eliminate the radical by raising both sides of the equation to the power of the index. We talked about this already, guys. If I have this example here, x plus 3 equals 9, guys, how could I get rid of a square root? By squaring both sides. And that's going to be x plus 3 equals 81. And then from there, I'm going to solve. How do I get rid of a cube root, guys? By cubing it. How do I get rid of a fourth root? By raising it to the 4th power. Now, let's really quickly investigate why that works. If I have the square root of x, guys, true or false, that's x to the 1/2. If I raise this to the 2nd power, guys, what do you do to the exponents when you raise a power to a power? You multiply them. So this is x to the 2 over 2, which is x to the 1. Do you now see why when you go square root of x squared, they cancel? Do you see it now, guys? I'm not being sarcastic. I just want you to really understand that. Same thing with any other index, brothers. If I have the 5th root of x, for example, and I raise it to the 5th power, it equals x. Okay, that's great, Moro. Why? Well, why? Because the 5th root of x equals x to the 1/5. If I raise that to the 5th power, when I raise a power to a power, I multiply the exponents, that becomes x to the 5/5, which becomes plain old x. Now, of course, you don't have to do all of this work. You already know that when I raise a radical to the power equal to the index, they're going to cancel each other out. But this is an explanation of why. Okay? Does that make sense, guys? Does that help a little bit? Hopefully. All right. So let's continue, please. So we're going to cancel out the radical, again, by raising both sides of the equation to the same power as the index. And then we're going to solve the resulting equations and check for extraneous solutions. Remember extraneous solutions. I don't know if you remember that, guys, but we talked about that when we were doing absolute value. Extraneous solutions are solutions that you will render, that will come out in your answer, but they don't work. When you plug them in, they don't work. So they're kind of like fake or false solutions. So, okay, let's do this. Let's solve each equation and check your answers for extraneous solutions. All right, guys, what's the first step we got to do here according to my rules? Isolate the variable, very good, or the radical. So you're going to add 5 to both sides. Square root of 4x plus 1 equals 5. How do I get rid of a square root? Yeah, I want to get rid of this radical, so I'm going to square both sides. Remember that whatever I do to one side of the equation, I must do to the other side of the equation. So this becomes 4x plus 1 equals 25. Subtract 1 to both sides. 4x equals 24. Divide by 4. X equals 6, maybe. Just plug it in. 4 times 6 is 24, plus 1 here is 25. Square root of 25 is 5. 5 minus 5 is 0. It works. Okay? Yes, sir. Thank you. Because now if I square both of these, you are going to have to do that eventually. But if I square both of these, now I have a perfect square.
Yeah, but what I'm saying is you just square them individually. So you do.
You cannot do that.
Why can't you do radical 4x plus 1 minus 5 squared equals 0 squared?
I'm sorry, come again?
So you square all 3 of them.
That's not the way it works.
Yeah.
No. That's not the way it works.
Radical 4x plus 1 squared minus 5 squared equals 0 squared. That will give you x equals 6.
Yeah, it's not really the way. I'm going to test it out. I will test it out in a second. Okay? Let's see. But wait a second. Because what you're saying is, hold on. What you're saying here is to square this, and then square this, and then square this. This is not the way it works.
Plus 1 minus 25 equals 0 plus equals 25 minus 1, 24, 4x divided by 24 equals 6.
Yeah, that's lucky.
All of them.
All right, we'll check it out. I'll check it out. If it is, then fantastic. Then I learned something new today, and I'll be extremely happy. So thank you for that. All right. Let me just, real quick. Now you're messing me up here. If I go ahead and get the radical by itself, let's see. I got squared, squared. Okay, so I got 2x minus 3 equals 25. And then I have 2x equals 28. So x equals 14. All right. What you're saying is, if I square this, that'd be 9. Plus then 2x minus 3 equals 64. 64 minus 9 would be 55. And then 55 plus 3 is, oh. Yeah, it's because you're wrong. Because you can't do it like that. I didn't think so. You can multiply. You can multiply. Yeah, you can multiply everything here by 2. But what happens is with an exponent, my brother, remember, that's why when you said it, I said you may have worked on this one because it got lucky because there was a 0 here. But you cannot just individually square things. Exactly. Thank you. When you're squaring, you're talking about repeated multiplication. If you were going to multiply everything by 2, yeah, that works out perfectly. But when you square it, it works out a little bit differently. That's why when I said that, I said, well, you could have gone like this, squared both sides, and now this is a perfect square. First term squared plus 2 times first times second, 4x plus 1, plus second term squared equals 0. Hey, you could do that. But that's going to be way too difficult for this particular problem. So, yeah, you always want to isolate the radical And then from there, once the radicals are isolated, then you can go ahead and activate that.
And did it also give you a full number because it gave you 29 plus 1 I thought it was.
No, no worries. Dude, and I thank you. I thank you. That's why we learn, man. We all learn here. So yes, please scratch the whole squaring individually. That does not work, unfortunately. I wish it did, trust me. I didn't think it did, but I was like, oh my goodness. If I could do that, woof, that'd be so much easier for my boys. But thank you. No, thank you for making me think. Okay, guys, I want to get the radical alone, so I'm going to subtract 2 to both sides. Square root of 3x plus 10 equals 2. So I'm going to square both sides. Cancel, cancel. 3x plus 10 equals 4. Subtract 10 to both sides. 3x equals negative 6. Divided by 3, x equals negative 2. We got to check it, though. 3 times negative 2 is negative 6. Negative 6 plus 10 is 4. Square root of 4 is 2 plus 2 is works. Does that make sense, guys? Promise? Okay, now, this one is a great one, and I want you to really pay attention. I promise you, you're going to see this on a test, and I'm probably going to get most of you on this. When I subtract 7 to both sides, my brothers, I got square root of 5x minus 1 equals negative 2. Stop! Hammer time. No, I'm just kidding. No solution. Okay, someone went, what? How could there ever be a negative out of a square root, guys? How? It's impossible. Square root of 4. It's 2. Yeah, I know you can have a plus or minus side, but the radical is never going to equal a negative value. Ever. Ever. Ever, 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 ever. Okay? So whenever you have a square root or an even root, a fourth root, a sixth root, an even root that equals a negative, it's no solution. Don't even worry about it anymore. Now, if it's an odd root, you got to continue, because an odd root can be negative, but a square root cannot. Okay? Does that make sense, boys? Yes, brothers? Okay. May I continue? Thank you, gentlemen. All right. All right, next. Now let's get a little bit, let's amp it up a little bit, guys, because life isn't always going to be easy. Solve each equation. Okay, now we're going to go a little different route. I got the radical alone, right? Okay, well, I'm going to square both sides. The radical cancels. I have x plus 5. But now, guys, this is x minus 2 squared, okay? I'm going to do this the long way, but this is why I've been harping on you guys. Learn your perfect square format. Learn your difference of square format. Check it out. This x minus 1 squared is x minus 1 times an x minus 1. So this is x plus 5 equals x squared minus 2x plus 1. Because x times x times x, negative 1 times x, negative 1 times negative 1. Or you could finally learn first term squared minus, because there's a minus here, 2 times the first term times the second term plus second term squared. You could do it either way. I don't care. But time is of the essence. So now I'm going to create a trinomial, which all of us know how to do. So this is 0 equals x squared minus 3x minus 4. Guess what? That's a trinomial. I can factor this. This 0 equals x minus 4 and x plus 1. So therefore, zero product property, x equals 4 and negative 1. But unfortunately, I have to check this, guys. I have to. I have no choice. So let's check them. If x is 4, all right, what's 4 plus 5? Square root of 9? 3. What's 4 minus 1? Okay, so they both equal each other. We're good. 4 works. Let's try negative 1. What's negative 1 plus 5? 4. Square root of 4? 2. Okay. What's negative 1 minus 1? Are they equal? So that guy right there is called extraneous. Yes, sir. I didn't flip the sign. I just used the zero product property. Thank you so much, my brother. Thank you, my brother. Thank you. Sir, my brother.
Will the negative always be the extraneous?
No, the negative will not always be extraneous. Most of the time it will if you have an even root. Yeah. But I don't want to say always because if it's an odd, it's going to be negative. Okay. Thank you, my brothers. Next, I subtract 4. Please don't fall into this trap. This is the cube root of 3x minus 12 equals negative 3. A lot of people are going to say, oh, no solution. No, it's a cube root. Thank you. So I'm going to cube it now. So this is 3x minus 12 equals negative 27. Add 12 to both sides, gentlemen. I got 3x equals negative 15. And x equals negative 5. And then negative 5 times 3 is negative 15 minus 12 is negative 27. What's the cube root of negative 27? Negative 3 plus 4 equals 1. It works. Okay? Does that make sense, guys? All right. And then this one is the same kind of thing. So I'm going to ask you, make a note of it right now. Do C on your own, please, tonight. And we'll check it tomorrow. But I want to continue because there's one other thing here. Okay? Sometimes equations contain fractions that have rational exponents instead of radicals. In order to solve equations of that form, you can convert the rational exponents into a radical. Or you can isolate the variable with the rational exponent, raise each side to the equation of the reciprocal of the given power, and you solve as normal. So basically what I'm saying here is, sometimes I'm not going to give it to you in radical form. Sometimes I'm going to give it to you in exponential form. You could do one of two things. You can convert this into radical form if you so choose. Or you can just raise both sides of the equation to the reciprocal of the original power. So first off, I got to get this alone, like always. So I'm going to divide by 3. So I'm going to have x plus 1 to the 2/3 power equals 4. Now, I can go, this is the cube root of x plus 1 squared. Yes, you can. I would not. I would remember my exponent rules. When I raise a power to a power, I multiply them. So if I raise this to the 3/2 power, these guys go bye-bye. I'm left with x plus 1. And then I have the square root of 4 cubed. What's the square root of 4, guys? No, square root of 4, guys. 2. 2 cubed is 8. So I have x plus 1 equals 8. Subtract 1 to both sides. X equals 7. Plug it back in. 7 plus 1 is 8. Cube root of 8 is 2. 2 squared is 4. 4 times 3 is 12. Bada bing, bada boom. Works. Okay? So just like B, I'm going to subtract 3 to both sides. I have 5x minus 1 to the 1/2 equals 7. Okay? I get rid of that power of 1/2 by raising both sides to the reciprocal, which is 2/1. 2/1 times 1/2 cancels. I've got 5x minus 1 equals 49. Add the 1 to both sides. So I've got 5x equals 50 divided by 5. X equals 10. Does it work? Let's check. 5 times 10 is 50 minus 1 is 49. Square root of 49 is 7. 7 plus 3 is 10. Works. As you can see, guys, you've got to know how to add, subtract, multiply, and divide, and quickly. We don't have time for dilly-dallying here. Okay? Make sense? Okay, I want to make sure it makes sense. So also, write it down for your notes. I want you to do C, which is the same exact thing as I just did, on your own. So that means if you forgot how to do it, hit play on the video and rewatch it. And last but not least, okay, now we're going to deal with solving equations with two radicals now. You're going to always have to isolate one of the radicals. Do not attempt to square both sides with both radicals in one side. You can do it. Yes, you can. It's going to be a mission. So please isolate one of the radicals. Just one of them. I don't care which one. Isolate it. Cancel out or eliminate radicals by raising both sides of the equation to the power of the index, just like before, and then solve the resulting equation and check for extraneous solutions. Let me explain how this bad boy works. Let's say I have something like this. Well, in this case, this is nice and easy. I have a cube root equals another cube root, so I'm going to literally raise both sides to the third power, because that third power cancels out that cube root, right? That's 1/3. So I've got x squared minus 4x minus 2 equals negative 3x plus 2. Now I'm going to create a trinomial. Thank you very much, my brother. So I'm going to add 3x and subtract 2 to both sides. Add 3x and subtract 2 to both sides. So I've got x squared minus x minus 4 equals 0. And I've got a little bit of an issue there. That is not factorable. Okay? At this stage in the game, we haven't learned the quadratic formula yet. At this stage in the game, for me, you can leave it just like that if I give you something, whereas you're solving, it's prime. You cannot factor it. There are solutions here, but you're going to have to use the quadratic formula. So if I give you something like this on a quiz or a test, which it's my goal not to do that, but if I do, leave it just like this. Stop right there. Okay? Make sense? Now, please pay attention to this next one, guys. This is the one that kicks everyone in the skull. So please pay attention. For B, I've got two radicals on one side. I want to isolate one of them. So I'm going to add square root of x plus 6 to both sides. This is the square root of 3x plus 6 equals the square root of x plus 6 plus 2. Are you guys with me here? Okay, this is what I'm going to do because I want to make sure that we have plenty of space to see this. Okay, so we're over here, all right? I'm going to get rid of this radical by squaring both sides. Okay? Actually, let me add one of these things. I'm going to square both sides. When I square both sides, guys, this radical cancels with that guy, giving me a 3x plus 6. And now, this guy over here, let's investigate this. When you have a square root of x plus 6 plus 2 squared, please remember that this means this is a square root of x plus 6 plus 2 times a square root of x plus 6 plus 2. And now I have to FOIL. Square root of x plus 6 times square root of x plus 6 is x plus 6. Square root of x plus 6 times 2 is 2 square root of x plus 6. 2 times square root of x plus 6 is 2 square root of x plus 6. 2 times 2 is 4. So now this would be x plus 6 plus 4 square root of x plus 6 plus 4, which cleans up to be x plus 10 plus 4 square root of x plus 6, and that equals 3x plus 6. So this part here, guys, you better remember that you're multiplying these polynomials. Give me a second. If you knew your perfect square formula like I asked you to memorize before, first term squared, x plus 6, plus 2 times the first times the second, 2 times square root of 6 is 4 square root of x plus 6, plus second term squared. That's the easy way. You don't want to do the easy way? You want to do the long way? No worries. I just did the long way for you. But now from here, we're not done yet. I'm going to subtract an x and subtract a 10. Subtract an x, subtract a 10. So I have 2x minus 4 equals 4 times the square root of x plus 6. Oh, this gets fun now. I'm going to square both sides. Now this is going to be 4x squared plus 16x plus 16 equals 16 times x plus 6. From here, I have 4x squared plus 16x plus 16 equals 16x plus 96. Subtract the 16x, subtract the 96, subtract the 16x, subtract the 96. 4x squared minus 80 equals 0. Factor out a 4. X squared minus 20 equals 0. Yes, sir. Yes, on the test you will have to do this. Yes. Yes. Don't worry about the number of problems. Worry about being able to do it, sir. Being at, well, time-wise, and I guess you better practice. Look, guys, I know you want to get to lunch. We will continue with this tomorrow. However, I want you to do the first two that I gave you, and I want you to do these two as well. Then from there, we'll review that, and we'll go to the last page. Okay? Get out of here. God bless you. Have a great day. Thank you. Bye-bye. Hold on, guys.